phase locked loop control. For the speed control of a servo system, closed loop control is normally used. The speed, which is sensed by analog sensing device, example tachometer, is compared with the reference speed to generate the error signal and to vary armature voltage of the motor. These analog devices for speed sensing comparing signals are not ideal and the speed regulation is more than 0.2%. The speed regulation can be improved if digital phase locked loop PLL control is used. This is the block diagram of converter fed DC motor drive with phase locked loop control, that is PLL control, and this is in the same block diagram with the transfer functions where this is the DC motor and the load part, and this is speed encoder, phase detector and filter, and this is converter. In a phase locked loop control system, the motor speed is converted to a digital pulse train by using the speed encoder. The output of the encoder acts as the speed feedback signal of frequency f0. The phase detector compares the reference pulse train of the frequency fr with the feedback frequency f0 and provides pulse width modulation output voltage VE, which is proportional to the difference in the phase and the frequencies of the reference and feedback pulse trains. The phase detector or comparator is available in integrated circuits. A low-pass loop filter converts the pulse train VE to a continuous DC level VC, which varies the output of the power converter and in turns the motor speed. When the motor runs at the same speed as the reference pulse train, the two frequencies would be synchronized or locked together with a phase difference. The output of the phase detector would be a constant voltage proportional to the phase difference, and the steady state motor speed would be maintained at a fixed value irrespective of the load on the motor. Any disturbance contributing to the speed change would result in a phase difference, and the output of the phase detector would respond immediately to vary the speed of the motor in such a direction and magnitude as to retain the locking of the reference and the feedback frequencies. The response of the phase detector is very fast. As long as the two frequencies are locked, the speed regulation should ideally be zero. However, in practice, the speed regulation is limited to 0.002%, as this represents a significant improvement over the analog speed control system. So for analog system, limited to 0.2%, whereas PLL is going to limit to 0.002%. This is regarding phase locked loop control. If this video is useful, please like, share and subscribe.